The second reaction that we're going to learn in section 17.9 is called saponification, which is a fancy way of saying making soap. So this is going to be the second time that we've talked about making soap. But this still isn't the time that we're going to talk about making soap. This is just still a warm-up of making soap. Saponification is when an ester reacts with water and, not just water by itself, NaOH or LiOH or KOH. And the product of this reaction is soap. So let's start by looking at a generic saponification. And we're just going to use a little tiny ester because it's easy to draw, but this would make a terrible soap, because if you remember last time we talked about soap, I told you that the good soap is going to come from a molecule that has a huge carbon chain hanging out on the end there. So this is ester plus water, so we've got our plus H2O, and then this time with our catalyst on the arrow, under the arrow, we're not going to have sulfuric acid, H2SO4, we're not going to have H+, nothing like that. We're going to have our strong base, NaOH, LiOH, or KOH. So maybe we'll start with LiOH, and I'm going to show you several ways that we could represent that catalyst, or that reactant. The product of this is going to look like this. So before we keep drawing, the esters, carbon-oxygen double bond, and the carbon-oxygen single bond, and the other side that's attached to the carbon-oxygen double bond. But instead of an OH, there's a negative charge on there, and the cation, lithium, is there with a positive charge. The other half of the ester, the carbon chain, the CH3, in this particular example, the CH3, like normal, gets associated with an OH right there. So we're still making an alcohol, but instead of making a carboxylic acid, we make a soap. So let's start with looking at a couple different ways that we could see this. So we could have NaOH, we could have KOH, we could have OH minus, or they're not even saying what the cation is. Or we could have, in one of your sapling questions, it says one equivalent of OH. One equivalent. So they're just talking about a mole to mole ratio with the OH. So let's draw a couple of these. And we're going to do, the first one that I'm going to do, let's do NaOH. So for the product, we're going to take our carbon-oxygen double bond and our carbon-oxygen single bond, carbon-oxygen double bond, carbon-oxygen single bond, and the other thing that's attached to the carbon-oxygen double bond, that stays there. And we are going to take the cation of the NaOH, LiOH, whatever it is. We're going to put charges. The oxygen gets a negative charge. The sodium, in this case, gets a positive charge. If it was a potassium, it would also get a positive charge. So there's that piece right there. And then our other product, we are going to have this piece from the ester right there. And we have something hanging off of it. What is attached to it? What's hooked up on that side over there? It is going to be the OH from the NaOH, just like that. Let's do one more example. This time we're going to do the 1 equivalent of OH minus to see how that works. So again, start by drawing your carbon-oxygen double bond and your carbon-oxygen single bond and all the rest of the stuff that's attached to the carbon-oxygen double bond. Just like that. And then look back up at our previous example. On the oxygen, the single bonded oxygen, we put our cation there. But in this example, we don't know what the cation is. They're not telling us. It just says OH minus. Could be LiOH, could be NaOH, could be KOH. We don't know. Since we don't know, we can't write it over here. So we have to just leave this as O minus. And we don't have Na plus or Li plus or K plus to add to it. The other half of this molecule is this little carbon chain right there. We do still add the OH to it. That hasn't changed. So the way that this is different is if there is no Na plus here, or K plus, or Li plus, it means also over here, we're not going to be able to draw an Na plus, or a K plus, or an Li plus. And we are going to actually talk about how to make soap in chapter 19. So we have a little bit of time still before we really talk about it for reals, but it's coming.